are recording. There we go. So we're just picking up where we left off last class. We're going to do more examples. So I want us, I don't know, what was our last example number last time? Was it 2 or 3 or 1? It was 2, so this is 3. I want us to find a 4th degree polynomial with real coefficients if 2 roots are 3i and 1 plus I. Now, if it's a 4th degree polynomial, how many roots should there be? 4 roots, exactly. If it's a 4th degree polynomial, that means our biggest exponent is 4, which means we should have 4 roots. I have given you 2 out of the 4, but these 2 roots that I've given you are both imaginary. So what does that mean we know? What do we know? Ready? Come on. Tejas? No? Really, guys? Sienna?
They come in like the opposite?
Yeah, that the opposite of it is also included. So if I have my first root is 3i, what does my second root have to be? Negative 3i. Remember, imaginaries come in pairs. And if my third is 1 plus I, its conjugate is also a root, which is 1 minus I. So I need to find the polynomial that gave us these roots. So what I'm going to do is I'm going to use sum and product to find the quadratic that gave me 2 roots at a time. And I'm going to use sum and product twice. So I'm going to take these 2 roots and use sum and product to find the quadratic that gave me those 2 roots. Then I will use sum and product again on roots 3 and 4 to find me the quadratic that gave me those roots. And once I find the 2 quadratics, what do you think I'm going to do with those 2 quadratics to find the original polynomial? We're going to multiply those 2 quadratics together, and that will give me the 4th degree polynomial. So let's go ahead and say we know R1 plus R2, the sum of the roots will be negative b over a. So I have 3i plus negative 3i is equal to 0. Is that okay? Yeah, it's absolutely okay. If I want to make this into a fraction, it's going to be 0 over what? 1. So that means my b is 0 and my a is 1. Now I'm going to find the product of these 2 roots. So we know R1 times R2 will give us C over A. 3i times negative 3i is going to be negative 9i squared. And we know negative 9i squared will be positive 9, which will give us C over A, so we're 9 over 1. I want to make sure my A's are the same. Are my A's the same? Yes. So we are set to write out our quadratic. Our A is 1, our B is 0, our C is 9. And now we're going to write ax squared plus bx plus c. So now we're going to be x squared. Do I need to write 0x, do you think? No, plus 9. Right, so this is one factor. This was actually a factor of our original polynomial. Now I'm going to find the other factor. Let's go back up. So now we know R3 plus R4 will give us negative b over a. So I have 1 plus I plus 1 minus I, which will give us 2 over 1, and that's negative b over a. So I found the sum of the roots. What am I going to do now? Find the product. So now we have R3 times R4 will give us C over A. So we have 1 plus I times 1 minus I, and that's going to be 1 plus 1, which is 2 over 1. How'd we get what? I heard somebody say, how'd you get, but I didn't hear the rest. How'd I get that? Okay. I just shortcutted it. I just did it in my head. But if you FOIL this out, 1 times 1 is 1. 1 times negative I is negative I times positive 1 is positive I times a negative I is negative I squared. The i's in the middle cancel, and I squared is negative 1, but then you have negative of that, the opposite of that, which becomes 1 plus 1. And that's 2. Okay, so here our a's are the same, so our a is 1. Our b, what did we say our b was? Well, if 2 is negative b, then b has to be negative 2. And our c is positive 2. So now our quadratic, which is in the form of ax squared plus bx plus c, will be x squared minus 2x plus 2. What should I do now? So I found the factor that gave us plus or minus 3i, and now I found the factor that gave us 1 plus or minus I. We're going to multiply them together. So now we're going to take x squared plus 9 times x squared minus 2x plus 2. X squared times x squared is x to the 4th. X squared times negative 2 is a negative 2x to the 3rd. X squared times positive 2 is a positive 2x squared. 9 times x squared is a positive 9x squared. 9 times negative 2 is a negative, 9 times a negative 2x is a negative 18x, and 9 times 2 is a positive 18. I'm going to combine my like terms, and that's only the x squareds. So we have x to the 4th minus 2x cubed plus 11x squared minus 18x plus 18. Now, did I say find the equation, or did I say find the polynomial? What were the directions? Find the equation or find the polynomial? James? Polynomial. Because I said find the polynomial, we're going to say p of x equals. What would I have written if I said find the equation? Good. If I said find the equation, I would not have written p of x equals. I would have written my polynomial and then set it equal to 0. That's the equation. But I didn't ask for the equation. I asked for the polynomial function, which will be p of x is equal to this whole thing. Okay. Let's keep going. Is 2 plus 3i a 0? Hi.
Sorry to interrupt.
Yeah.
David was in the bathroom vomiting, so we
Oh,
just took him to
no.
the bathroom.
Okay, thanks.
Took him to the nurse.
Okay, thank you. Thanks. Is 2 plus 3i a 0 of x to the third minus 2x squared plus x plus 6? What do you think the best way to do this problem is? Philip? Synthetic, exactly. The best way to do this problem is synthetic. So let's go ahead, set up our synthetic. We are going to do 2 plus 3i in the box. Is every exponent accounted for? Looks like it, right? 3, 2, 1, constant, we're good. So now we're going to write out our coefficients, 1, -2, 1, and 6. Bring down that 1. 1 times the quantity of 2 plus 3i is 2 plus 3i. What happens with the -2 and the +2?
Cancel.
They cancel. So now I'm left with 3i. Over on the side of my paper, I have to distribute in that 3i to the quantity of 2 plus 3i. 3i times 2 is 6i. 3i times 3i is 9i squared, which just gives us -9. So here we're going to write -9 plus 6i, which is going to be -8 plus 6i. All right, chances that we multiply this and our answer is -6 is slim, but we're still going to do it just to make sure. 2 plus 3i times -8 plus 6i. We're going to now FOIL it out. So we are going to get -16, sorry, 2 times negative is -16. 2 times 6i is 12i. 3i times -8 is a -24i. And 3i times 6i is 18i squared. Well, guys, you tell me, is this -6? No. So we can stop right here. When it says, is 2 plus 3i a 0, we are going to say no, because the remainder is not 0. Okay, so now I'm going to throw a little bit of a curveball, but not too bad. Given, oh no, actually, I think we've done ones like this. No curveball. Given 2 minus 3i is a 0 of, to the health office, sure. Guys, David's at the nurse. Can somebody bring his bag down there to him? Anybody want to do that?
Where's his bag at?
Right there. Thank you. We'll wait for Danny to come back. I'll finish writing the problem and then we'll wait for Danny. Given 2 minus 3i is a 0 of x to the 4th minus 4x cubed plus 14x squared minus 4x plus 13. Find all other zeros. Okay, so I've given you one root. It is a complex. Since I've given you one complex root, what does that mean? No, not synthetic. Good. Its conjugate is also a root. So if I give you an imaginary or complex root, its conjugate is also a root. So 2 plus 3i is a root. How many roots should I have? 4. Right now, is there any way to figure out the last 2 roots based on the information right here? No, not right now. It's okay. Oh, okay. Hi, you might want to sanitize.
What?
You probably want to sanitize. Because he's sick.
I was actually really tempted.
Okay. So these are 2 out of the 4 roots. Now before, what did we do? We had 4 roots, and we were finding the original polynomial. That's not what's. Oh, I'm sorry. That's not what happened. That is not what's happening here. What's happening here is I have their polynomial. I have 2 out of the 4 roots. I want to find the other 2 roots. Can I find the quadratic that gave me these 2 roots? Yeah. Why will that be helpful? Any ideas? Danny?
So like, let's say you find the quadratic, give you those 2 roots, and then you divide that quadratic in the main one, and then you take the one, and then you take the quotient or whatever of that, and then you use the calculator.
No calculator. You were so perfect until you said calculator, but you got it. You got the general gist of it. We're going to do this. We're going to find the quadratic that gave us these 2 roots. We're going to take our original polynomial, divide it by our quadratic. That will give us the remaining factor, which will get us to the remaining 2 roots. Let's do it. That's the plan. So I'm going to do root 1 plus root 2 is 2 minus 3i plus 2 plus 3i, which is going to give us 4. This is 4 over 1. This represents negative b over a. Then I'm going to find root 1 times root 2, which is 2 minus 3i times 2 plus 3i. This is going to give us 4 plus 9. That is 13 over 1, which gives us c over a. So now let's write it all out. My a is 1, my b is negative 4, my c is 13. Am I going too fast or are we good? I'll let you all catch up. Okay, so now we have ax squared plus bx plus c. So we have x squared minus 4x plus 13. So this is our other factor. This is the factor that gave me the root of 2 plus or minus 3i. What we're going to do now is divide. I'm going to take this and the original and divide them. Long division. So we have x to the fourth minus 4x to the third plus 14x squared minus 4x plus 13. And we're going to divide that by x squared minus 4x plus 13. How come I couldn't use synthetic division here? My only option is long division. Why was I not allowed to use synthetic? Tori? Good. It's not a binomial with a degree of 1, right? We usually need the degree to be 1. This is not a degree of 1, so we are forced to use long division. Here, x squared times what will give us x to the fourth? X to the second. I'm going to take that, distribute it in. We get x to the fourth minus 4x to the third plus 13x squared. Because we're subtracting, we need to change all the signs to the opposite. The x to the fourths cancel. The 4x to the thirds cancel. And then we have 14x squared minus 13x squared gives us 1x squared. And we will bring down everything else. So x squared times what will give me x squared? 1. We're going to distribute that in. And because we are subtracting, we change all of the signs. And what happens? Everything cancels out to 0. Should it cancel out to 0? Does that make sense? Yeah, why? It has to. Philip? Because it's a factor, exactly. If it didn't, that means we did something wrong somewhere. Okay, so our remaining factor is now x squared plus 1. We're going to set that equal to 0. I don't need to use the quadratic. I don't need to factor. I can just solve this. X squared equals negative 1. Square root both sides. What does x equal? Plus minus I. So now if we list it out, root 1 was 2 minus 3i. Root 2 was 2 plus 3i. Root 3 was I. And root 4 was negative I. Those are our 4 roots. Yes.
So only imaginary numbers come in pairs?
All imaginary numbers come in pairs.
So like if there was a problem to the third degree and you happen to know one of the zeros is imaginary number, that means there's only one real answer and the other 2 are imaginary?
Exactly. Tejas?
When you're writing out the roots, do you have to like write it out?
Nope. You could say roots 2 plus or minus 3i plus or minus I.
Is like the changing the sign when you know because it's like a pair? Is that like interchangeable? Could it be like 3i plus or minus 2, or does it have to be?
No, the imaginary one is always the one that's plus or minus. The I is always what's plus or minus, because how do you get that I? You get that I by taking the square root, and when you take the square root, that's what gives you the plus or minus. So it's always the I that's plus or minus. Any other questions? All right, 2 more problems and then we're done. Yes, Kai? No, doesn't matter. That was number 5. Write a polynomial Actually, I'm going to change it up. I'm going to say write an equation of a polynomial function of least degree with real coefficients whose zeros are 6 and 4 minus 2i. Right, I'm going to have you do this one on your own, but let's see. If I'm asking for a polynomial function of least degree, well, I know the zeros I have definitely are 6 and 4 minus 2i, but because I have a complex root, what do I know there has to be? Okay, Jess. There has to be another, right, opposite of the 4 minus 2i. It's conjugate, exactly. So I know root 1 is 6. Root 2 is 4 minus 2i, so that means root 3 has to be 4 plus 2i. Because there's at least 3 roots here, what is the least degree polynomial we have? 3. So you need to find the polynomial function that gave us these 3 roots. So you guys go do that now, and then we will go over it.
What'd you get? X cubed minus 14x squared is 24x minus 1 minus 6. Why did you do the sum of product of root A and root 2? So you go for these two, but oh, you get the division too. Like only know the other one's x minus 6.
You guys could work together.
No, Max,
X cubed minus 14x squared.
I figured out what polynomials to do when you like the R1 plus R2 and then like the R1 plus time.
Yeah, and then you multiply by x minus 6. Because the first root is 6, so that's
That's kind of hard to figure out the conjugate.
Oh wait, yeah, you're right. I see.
No, you messed up. Oh, I messed up the sign.
I did.
I figured out how to do it.
I wrote the whole Bible.
Oh wait, no, I'm a.
So rely.
No, I didn't get
I got minus 24 x because
You know what? I'm
And I just
in.
multiplied it by 6 and that's not.
Oh, Danny, no, you're right, you're right.
Would you get C?
How did I multiply 6 equals 1? C was 20.
Yeah, I said it was E.
I get this right. Huh?
What you doing with the roots? Are you just trying to find it?
So then that would be minus. Yeah. Times 120.
Yo, that x cubed minus 14x squared plus 60x minus 77. I think that's a little bit max equals.
1 second.
What'd you get?
No, I did it right the
Minus
first time.
14x squared plus 60x minus 70. 68. 68x
I got
minus 1.
x cubed minus x cubed minus 14x squared plus 3x minus 1.
I don't know, I hate it.
Oh, what is doing?
Oh, you have to multiply by x1 credit, like the factor. So like 6 is the
I actually did it earlier.
What is it called?
Oh,
that's
so long. I was yesterday
But
morning.
like, you know,
You already had the
minus
Well,
6.
it depends on your teacher. Tell them about ABC.
Because once you start to get your
It's not hard. It's not hard.
What's solved right?
What is your equation?
Oh, well, I want to like major in
You
computer
don't
science.
want to make it.
Well, I'm not. I don't want to take this up early because I want to be able to retain it.
That's easy. It's easy to say. CSA is that's one that's hard.
Yeah, so like if you don't want to go to computer science, you don't want to do
CSA is hard.
No, actually, well, yeah, the other two, then it's just.
What you got rated by the both of you.
It only gets.
CSP is like.
It was a gang.
Twice. I mean, once. I used to do some product and was doing great. And then I would have changed root one.
I didn't even then 5 to get they used to yelling.
Where method 2 comes in, you put it back to the factor. Yes.
Hair tie?
And then I would multiply them. But you could have used method 2 from the beginning. But if I used method 2, I would have used it on root 2 and root 3. And then.
Your mom is not.
Are we ready to go over this? Let's do it. Yes.
There's no way you have your hair back in
Okay, so my recommendation is let's find the factors that gave us these roots. So the factor that gave me root 1, this is x equals 6 is the root. Do we agree? So what's the factor that gave me x equals 6? X minus 6. Now, I need the factor that gave me the roots 2 and 3. And I know it's the same factor that gave me those two roots because they're conjugates, right? They have to do the plus or minus. So in order to find the factor that gave me root 2 and 3, I'm going to use sum and product. So we are going to have root 1 plus root 2 is going to be 8 over 1. That's negative b over a. Root 1 times root 2 is going to be 4 plus, oops, not 4, sorry, 16 plus 4, which is 20 over 1. That gives me c over a. So now we are going to have ax squared plus bx plus c. So we are at x squared minus 8x plus 20. So now I'm going to take this factor and the x minus 6 factor, and what am I going to do with them? Multiply them. X times x squared is x cubed. X times negative 8x is a negative 8x squared. X times 20 is 20x. Then we're going to have Negative 6 times x squared is a negative 6x squared. Negative 6 times negative 8x is a positive 48x. And negative 6 times a positive 20 is a negative 120. We are now going to combine our like terms. So I'm going to get x cubed minus 14x squared plus 68x minus 120. Now, did I say write an equation or find the polynomial?
Write an equation.
Write an equation, so we're going to say equals 0. All right, last problem for today. Yes.
So if it was find the polynomial, will we do like f of x equal?
Yep. Anything of x. F of x, g of x, p of x, anything of x.
Can you do k of x?
Whatever you want.
Can you do x of x?
No.
Can you do I of x?
I wouldn't, but you could. Capital I of x. Okay, so here, this is number 10 from our worksheet that I'm going to assign as homework, number 10. Okay, so I'm going to throw a little bit of a curveball in here. Find the polynomial with zeros of 4 and 2 plus I, and p of 1 is equal to 5. Okay, I'm going to ignore the whole p of 1 is equal to 5 right now. Let's just sort of put it on the back burner and focus on the other part of this. Find the polynomial. So I know root 1 is 4, root 2 is equal to 2 plus I, which means root 3 is 2 minus I. So I'm going to change this back into a factor, x equals 4, so this is x minus 4. And then I'm going to find the factor that gave me root 2 and 3. How do you think I'm going to recommend we find the factor that gave us root 2 and root 3? Sum and product. So we are going to get R1 plus R2 is equal to 4. So 4 over 1 is equal to negative b over a. I did root 1 and root 2. Root 3 and root 2. There we go. Root 2 times root 3 is going to give me 4 plus 1. So that's going to be 5 over 1, and that's c over a. So my a is 1, my b is negative 4, my c is 5. So we are at x squared minus 4x plus 5. What am I going to do with the two factors? Multiply them. So we're going to get x to the third minus 4x squared plus 5x minus 4x squared plus 16x minus 20. So now we're at x cubed minus 8x squared plus 21x minus 20. So p of x is x cubed minus 8x squared plus 21x minus 20. But we're not done, right? What did it say? P of 1 has to be 5. So this is saying I have p of x. This is p of x. So they're saying p of 1 has to be 5. So when I plug in 1, what should it simplify to? 5. So they're saying p of 1. Well, let's see what p of 1 is. P of 1 is 1 cubed minus 8 times 1 squared plus 21 times 1 minus 20. So we're 1 minus 8 plus 21 minus 20. So this is going to be negative 7 plus 1, which is negative 6. Is that 5? No. What does that mean? That means my polynomial must have a GCF of some number that I'm not going to call it A. What letter have I not used yet? W. All right, so now I know there must be some GCF of W. And when I have that GCF of W, we want it to come out to what number? 5. So this has to equal 5. Can I solve for W? I sure can. Divide by negative 6. So W is equal to negative 5/6. So my polynomial function, P of x, is going to be negative 5/6 times the quantity of x to the third minus 4x squared plus 5x minus 4x squared. Oh, sorry. That was my unsimplified one, sorry. X to the third minus 8x squared plus 21x minus 20. You should know how to do something like this. Yes.
Why was it P of I in the equation?
It wasn't P of I, that's P of 1.
Oh.
It was P of 1 because it said P of 1 has to equal 5. Did everybody get it? Yes.
So we don't have to distribute it.
Nope, you do not have to distribute in the GCF. We leave it just like this. All right, we are done.